So welcome to this session on message-driven microservices and monoliths with Micronaut. And that's quite an alliteration, but in essence, it's a very interesting topic, I find, and one that some people may not be as familiar with. I'm going to keep it very simple as possible, try to use some real-world examples, and try to hopefully be something that you can learn from. Our remote's dead, so let's go to the mouse. So here is Oracle's safe harbor statement. And essentially, please don't use anything I'm saying today to make any purchases or anything like that. So about me, I am Todd Sharp. As I said, I am a developer advocate at Oracle. I work with cloud and cloud databases. So essentially what that means is I work with developers and learn what they're working on, learn what they're doing, what kind of technologies they're using, how they're using Oracle technologies, how they're using other people's technologies. And I take that information and I bring that information to our product managers and our engineering groups and some other stakeholders within Oracle and try to use that information to make better products. So it's both an inbound and a kind of an outbound type of role where I take your feedback in, but also I do some evangelizing, some advocating, some training, some sessions like this to kind of spread the good word, show you how you can use some of our technologies and some of our cloud platforms and a lot of our databases and things like that. So previously, I worked at AT&T and a consulting firm called Booz Allen Hamilton. Got 17 years of full stack experience going back to 2004. Starting with Cold Fusion, believe it or not, and eventually moving into Groovy and Grails, and more recently doing a lot of Java work. On the front end, I have a lot of experience with all kinds of JavaScript, from vanilla JavaScript to Angular to back in the day using Moo tools and Prototype and EXTJS and some of the other nightmares that we had to deal with back in the mid-2000s, right? As well as done some work with Node, a little bit with Python. I try to kind of do as much as I possibly can in the software world. So in this session, you're going to learn, hopefully, how to use messaging reliably to communicate between distributed services using popular tools and services and the Micronaut framework. So I say distributed services. Notice I said distributed services and not microservices. And the reason I say that is because when we're thinking about messaging and we're thinking about modern application architectures, right? I think there's somewhat of a line blurring that is pretty common. A lot of people say they're using microservices when they might not be using a pure, what you might say by the book type of approach for microservices. And I think some people might feel a little, what's the word I'm trying to think of? Some people might feel a little slighted if you say they're using a monolithic approach, because it's really never that simple, right? I mean, even in a traditionally monolithic type application, you do typically have some kind of distributed services that need to talk to each other. And so it's not always straightforward. It's not always something you could put a label on or put a very specific, clear definition to. Modern applications are complicated and architectures are different and unique, and each one is different, right? But messaging is something that I think can benefit any type of application, no matter what the architecture. So before we jump into things, and we're going to look at some code, a lot of code today, using kind of hopefully what I consider a real world type example. But before we do that, I would like to take a look at a comparison of some messaging options, right? Because I think it's good to set the expectation on what we're going to be looking at and kind of give a 10,000 foot view of the different options out there. So as you can see in this slide here, the first two rows, I would say, are generally pretty similar. And those are Kafka and AMQP, Advanced Message Queuing Protocol. And the AMQP implementation that I'll be looking at today is called RabbitMQ. And it is a basically an implementation of AMQP that's written in Erlang, I believe. But it's been around for quite a while. But essentially, I think the first two rows there are very similar. Obviously, depending on who you talk to, those throughput numbers probably are going to look a little different, depending on the implementation, depending on scaling and things like this, right? But essentially, those two are used as message queues to produce and consume messages. A lot of times, most of the time, for microservices messaging between microservices, for metrics, publishing and consuming, log aggregation, analytics, all these types of things. Now, the bottom row, and that's the one we're not going to look at today, but not to discount at all anything from what it is, the bottom row there is MQTT, and MQTT stands for Message Queuing Telemetry Transport. And despite the name MQTT with the Q in the name, there's no queuing involved, right? So when we're talking about Kafka and AMQP, you can produce messages and they are queued in a queue on the broker until they are consumed. And there are different settings and so forth as to whether or not the message is dismissed or if it's retained and so on and so forth. But just at its very basic, we're talking about message queues. And with MQTT, it's really just a pub sub thing, right? So you publish a message, and if a client is connected to subscribe to that message, it receives it. If not, the message disappears into the ether, never to be seen from again. And you may think there's no use for that, but indeed there actually is when it comes to things like IoT and other lightweight types of situations. That's a very good thing to have. It's a very, it's low bandwidth. It's originally it was created for, I believe in 1999 for messaging from oil pipelines, right? So these oil pipelines were out in very remote areas. They were connected via satellite. So they needed a way to send sensor data from these oil pipelines back to wherever they needed that, to consume that data. And so they created MQTT as a way to very lightweight, very simple, publish this data and consume it on the other end. So those are the three really main things that we were talking about when we talk about messaging. So in today's session, we're going to kind of look at an e-commerce type workflow because I think it's simple. It's a little bit contrived, but I think it's simple. And I think it's a good illustration of why you would need messaging when it comes to distributed type services. So you think about a typical e-commerce, and if you're, my wife, for example, is a huge fan of Amazon, proven by the number of boxes that arrive at my house every day. But if you think about something like Amazon or any other e-commerce retailer, right? What happens is a user comes into the system, logs in, and places an order. Now, you can imagine that that's probably handled by something like an order service, right? So the order comes in, the order is placed. What happens next? Well, to greatly simplify things, the order is then shipped. Okay, that's great. That's usually probably handled by another service, I imagine. Not always, but let's go with this as an example. So you have an order placed, an order becomes shipped. Well, what happens then? Well, at that point, if I were to log into the system and take a look at my order, at that point, the order is probably still in like a pending status. So typically what happens is the shipping service needs to let the order service know that the order has been shipped. So it's kind of this back and forth communication that needs to happen, and it needs to happen reliably, obviously. So services need to talk, right? So the order service needs to talk to the shipping service needs to talk to the order service. As I said, I've been around for 17 years, and I've seen a lot of different things in those times, but most of the time on the small scale applications that I would work with, a lot of this communication would happen via HTTP or REST, right? You would make a call to the service via an exposed endpoint, tell it an order is received. The shipping service would then make a call back to the order service, letting it know that the order's been shipped, so on and so forth. Well, what happens when that line of communication, that HTTP pipe, whether it's from network issues, whether it's because the server went down, what happens when there's a partition in that connection, right? There's a break in the communication between these two systems. Well, in the old days, at least on the systems that I worked with, unless you have some kind of mitigation strategy or queuing in your application code itself, it usually meant game over, right? You could be receiving orders that would never ship. You could have shipped orders that are never updated in the order system and never move from a pending to a shipped status. So it's bad news. I mean, this, in fact, if you look back in the early days of major e-commerce on the web, there were notable disasters for bigger companies that was caused by similar things like this, right? So we needed a solution. Well, what is that solution? Well, enter messaging, right? So in this first example that we're going to look at today, we're going to use Kafka as a message broker. And what Kafka will do is Kafka will sit in between that order service and that shipping service, not technically sit in between, but theoretically sit between those two services and basically handle communication between those services, right? We can publish orders from the order service to the Kafka broker, and we can consume those messages from the shipping service, as well as vice versa, go backwards. Shipping service can publish messages that the order service can consume. And we're going to take a look at that just in just a second here. So the first thing I want to show you is how to get started with Kafka. Now, we only have so much limited time in this session, and Kafka, I mean, you could go really deep with Kafka if you wanted to. There's some amazing presentations out there. There's some great developer advocates for the Kafka platform that would certainly show you all kinds of very deep stuff with Kafka. We're going to stay really high level with this and just basically turn up a local broker and use it for some simple messaging. First thing you have to do for that is to download Kafka. And Kafka is bundled. It's you can download it basically an archive of the entire Kafka broker using a simple mirror. I've already done that, so I won't do that step here. But once you unzip it, you can then start up Zookeeper and start up your Kafka broker. Now, Zookeeper is a dependency that Kafka has. I believe it's going away in the future. But for right now, what Zookeeper does is it just kind of handles the configuration and meta type information for Kafka. Zookeeper is a meta store for Kafka. So you do have to start up Zookeeper first before you start up your broker. But when you download Kafka, as you can see here, there is a bin directory in the directory where you unzip it. And it has all these handy scripts, bash scripts. And I believe there's some batch files as well if you're using Windows. But essentially, these really quick shortcut scripts to get these things up and running locally. So there's a Zookeeper server start shell script, bash script, and there's a Kafka server start bash script. And a default configuration file is also provided for you in the config directory. So let's do that. Let's get those things up and running. And to do that, I'll open my terminal here. And I'll just call, in this case, the Zookeeper server start, and I'll pass it that config file. So that's going to open up Zookeeper in a new tab here for me. And once that's going, I will start the broker, and that will open itself in a new tab here. Excellent. So now I have Zookeeper and Kafka running just by running two simple bash scripts, and they're running in two separate terminal windows for me here. What do we do next? Let's hop to the next slide and take a look. So Kafka has this concept of topics, and a topic is just like a channel that your messages are sent back and forth on. So the first thing we need to do to get started is to create a topic, and we do that with the Kafka topics bash script. So I have some quick shortcuts here, and I will create a quick topic called test. And you can see a little bit of activity in my Kafka broker down here. And essentially, we get some feedback that it has created the test topic. While I'm here, I'm also going to create an order topic that we're going to use in our further demos, as well as a shipment topic. So I've created my 3 topics, and we're going to take a look at the test topic from the terminal window before I move any forward. So the terminal topic, now we can now launch consumers and producers right in our terminal here. So if we use the Kafka console consumer script, and we pass it the name of the topic and the server, we can open a consumer right in our terminal. Oh, you know what? That's all right. I'll leave it there. So that opened the Kafka consumer in that top window there. And if I just go back to there, source my shortcuts, we can now open a test producer in this window. All right. Excellent. So now we have a producer and a consumer. And if we go down to the producer and we type a message and hit enter, we can see that our consumer has consumed that message. So very cool, very quickly, very easily, in less than 5 minutes, we have created topics, created a consumer, created a producer, and produced a message on that producer that got consumed by our consumer. May sound like a lot of kind of crazy terms that we're getting thrown at you if you're new to all this, but hopefully it makes sense. Producers produce, consumers consume. Topics are just the channel on which those messages are sent. So great, excellent. Let me close out of that and close out of my consumer and clear that terminal, and we'll head back to the slides. All right, so at this point, hopefully you're feeling a little more comfortable with what Kafka is, how to get up and running with it. And the next step we're going to take a look at here is how to actually use this Kafka broker from our Micronaut application. And hopefully you're familiar with Micronaut. If not, I encourage you to check it out. It's very great. The documents are very easy to follow. But assuming that you have created a Micronaut application before, I've already created the application, and we'll take a quick look at that application at this point, and we're going to enhance it to use messaging. So if I open up my IDE here, hopefully you can see that well. The first thing that I did was went to launch.micronaut.io, and I bootstrapped this application, and I made sure to include the Kafka feature so that all of the dependencies that I need are already bundled with this application. And the first thing we need to do to talk to this Kafka broker that we have up running locally is to add this minor bit of configuration that tells Micronaut where the Kafka Bootstrap server is located. In this case, it's at localhost 9092. And this being my order service for my e-commerce example, I have it named order service, and it's running on port 8080. So excellent, that's great. Let's take a look now at the domain objects. So I have here in this application some very simple domain objects created. And the first being an object I'm calling order. The order has an ID, it has a customer ID, a total cost of the order, and a shipment status. And shipment status is just a simple enum that has 2 different values, pending and shipped. So when orders are placed, they'll get assigned an ID, they'll receive a customer ID and a cost, and they'll be put into the pending shipment status. So far, so good, pretty easy, makes sense, right? Next up, take a very quick look at the controller. The controller is nothing fancy. just a way to put a web front end on this order service so that I can mock placing and retrieving orders. So nothing special, just inject what we're going to look at next, and that is the order service. So the order service is injected into the controller. And if we take a look at the order service is very simple. I don't have any persistence in this example. I'm just storing orders in a list inside of in memory. But of course, we could easily add persistence. We can hook this up to a database using Micronaut data, which is very easy to do. But I wanted to focus things on the actual messaging aspect here, so I'm just storing things in memory. Now, the order service has several methods. It has a get order by ID method, a list orders method, an update order method, and a new order method. So the new order just receives an order and adds it to that in-memory list and does a little bit of logging and returns that order back to the user. So pretty easy, pretty straightforward, pretty basic. We can, at this point, if we ran the service, we could place some orders and see how that works. So let's launch the application here quickly. And now that it's up and running, we can come over to Insomnia and we can place an order or two, and we can see that those orders get immediately put into pending status. If we get all orders, we can see a list of all of the orders that we just created. So far so good. Makes sense, pretty simple, basic, easy to follow, right? All right, so at this point, we are ready to start producing messages from this order service. We're ready to tell basically the shipping service that an order has been received. So let's modify this order service in order to do that. And to get started with that, the first thing I'm going to need to do is create a order producer class. Now, I can do this with the Micronaut CLI using the mn create Kafka producer command and just passing it the path to, I just heard some beeps there in my ear. Hopefully Zoom is still connected. It looks like it is, so forgive me for that. All right, sorry for the interruption. So we're going to create a Kafka producer. So let's create that, and let's come back up to our application and take a look at the order producer. So the CLI gives us this interface, bootstraps it for us, and you can see here it's annotated with @Kafka client. So this is a very simple interface, and the beauty of Micronaut doing a lot of what it does at compile time gives us a really nice feature in the case of our order producer, and that is we can declare this as a interface. We can create some method signatures, and at compile time, Micronaut is going to create a concrete implementation of this, and it will be ready for us to use at runtime, which is really, really handy. So let's do that. And to do that, we just create a simple method signature for a send message method. We annotate that with @topic and tell it the name of the topic that we created in Kafka. And it has two arguments. It has a string containing the key or a unique identifier for the message, and that's annotated with @Kafka key. And the second argument is the body of the message. What do we want to send inside that message as a body? In this case, I have told it that the order domain object is the body, and Micronaut is really smart. It's going to serialize that as JSON, so we don't have to worry about any of that nonsense. We could just pass it in order, and it's all good. So we have an order producer. Now, what do we do with the order producer? Well, if we come over to our order service, we can now inject that order producer into our order service and come down to our new order method, and we can use that order producer. So very simply, very quickly, in very few lines of code, I have added the ability to produce messages from this order service. Now, if I save this and I run that application, and we come back over to our terminal and we create an order consumer, So we have an order consumer now running in our terminal. We have our application running in on the server. And now we can place a few more orders. And you can see, just as the last time, our orders are in pending status. But if we come over to our consumer, we can see that our consumer is receiving those messages. Excellent. So we're placing orders, messages are being sent to Kafka, and we're able to consume those orders. Perfect. Excellent. Let's move on to the next step. So what's the next step? Let me shut down this application really quickly. And we're going to now focus on the shipping service. So if we come over to the shipping service, you can see that same configuration, localhost 9092, my shipping service. This one's going to run on port 8081 because our order service will be running on port 8080. And of course, we don't want to conflict between the two. So our shipping service is essentially pretty basic. Again, we have that same order domain object, and this time we have a shipment object, and the shipment object has an ID, an order ID, and a shipped on date. So very basic, very simple, just as before. We also have a shipping service, and in the shipping service, again, uses a list. I don't like that that's red. Why is that red? That should not be red. Well, let's go with it and see what happens, right? Okay, so we have a list of shipments, again, in memory in the shipping service. This one's a synchronized list just to keep it thread safe because we might have multiple orders coming in at the same time and we want to keep it thread safe. So, excuse me. So our shipping service has a few methods as well: get shipment by ID, list shipments, update shipment, and new shipment. Now, did I do something over here? Why? Okay. Okay. I don't know why we have some red lines here, but we will certainly find that out when we run the application. So we want to consume those orders, right? So let's create a consumer, Kafka consumer, in our shipment service. So to do that, we use mn create Kafka listener instead of Kafka producer. And if we run that, come up to our application, we can take a look at the order consumer. Now the order consumer is a very basic class. We're going to use the latest offset instead of the earliest. And this is annotated with @Kafka listener. And it's a basic class that we can use to start consuming messages from our order topic. Now to start consuming messages, first thing we're going to do here is inject our shipping service into our consumer, right? Because when we receive those messages, of course, we want to generate a new shipment from our via our shipping service. So we've got that injected. Now the next step is to add a method. And this method is, boy, it's driving me crazy that this order is red. Something is definitely goofy with my code here. And that is going to hurt at some point, but let's keep going. So our order consumer. So the order consumer has a receive method, and it receives the message key that we sent from our producer. And using RxJava here, we have a single order object, and that is represented by an order flowable. Now, the only thing we have to do at this point is call the doOnSuccess method of the order flowable and pass it a lambda, and that lambda will receive the order. So every time a message is received, this method will be called, and this is what we do with it. So basically some basic logging that we have here, and we use our shipping service to create a new shipment, passing it the order, and then some basic logging on that side of it. So if we try to start this one up, guaranteed it's probably going to fail because of whatever that issue is. Well, it didn't fail. So I think IntelliJ just might be a little confused, which is great. But now, if we come back over to our order service and we run that, and make sure that our shipping service is still running. Great, excellent, perfect. So as soon as our order service starts up, we can place another order. And this time what happens is the order service will produce a message saying that the order is received, and the shipping service should consume that and create a new shipment. So let's give it a try. If we click send on the place order method a couple times and come back over here to our order service, we can see that a few orders have been placed. And if we come over to our shipping service, we can see that those messages were consumed and the new shipments were created, right? So I placed a couple orders and we received a few shipments. Great, perfect. The messaging solution that we are developing is working perfectly. The messages are being passed, published, and consumed as expected. Now, what happens if we think back to that slide where we cut the cord? What happens if our shipping service goes down? If I turn off my shipping service right here, and I come back over here and I place some orders. I place 3 orders, 4 orders, 5 orders. These orders are coming in fast. We've got a great sale going on our e-commerce application. People are buying all kinds of things, placing all kinds of orders, but our shipping service is down. Maybe there was a network issue. Maybe there was a hardware issue. Maybe there was a server issue, whatever. These are all piling up now, right? And that's, in the past, bad news. Well, as soon as our shipping service comes back online, and you can see as we started it here, you can see that those orders are still received and processed as they would be if the service was online the whole time. So that's the beauty of messaging, right? You can have this asynchronous type communication that is not dependent on a network connection between the two services or anything like that. We're not going to miss any orders. We're still going to create all our shipments. Everything is going to work as we expected them to. Now, if we think back to the slide where I described the order workflow, at this point, our shipping service, of course, we want to start telling the order service that the orders have been shipped. So to do that, we want to create a shipment producer. And we do that again with create Kafka producer. And we can come in here. And inside of our shipment producer, we can say, have a send message method that this time sends a shipment object on the shipping topic. And if we come back to our shipping service, we can add, we need to first inject that shipment producer into our shipping service. And now that it's injected, we can come down here and we can send that message back to the order service. So if we save that and rerun that and come back over to our order service and stop that. And this time we want to create a shipment consumer so that we can consume those shipment messages. So it's kind of that reverse workflow that we just created from the order to the shipment. We're creating that backwards now from the shipment back to the order. If we open up our shipment consumer, change the offset to latest, and in our shipment consumer, we inject our order service. We have a receive method that receives a shipment, single shipment. And inside the do on success, we're going to do some logging, and we're going to finally retrieve that existing order by using the shipment order ID, update the shipment status to shipped, and then update the order in our database, our in-memory list, right? So we start that up, take another look at the shipping service. It's up and running as expected. wait for our order service to get running. Let's take a quick look back here at our shipping service. And I want to show you one thing here inside of our order consumer. So this right here. So as I said, shipping is slow, right? And this could, it's another really a good use case for using messaging, right? You don't want to, if you have a slow process or something that's very intensive or that relies on a serverless function or external APIs, whatever you need to do, that could be slow. So of course you don't want to block when an order is placed to wait for that shipment to be created. It's best to just fire it and forget it, and then the order shipment would be updated as necessary. Because a lot of times, I mean, think about Amazon. If you place an order and immediately went to the order status page, of course, it's not going to be shipped immediately. But there, billing, for example, is another example. Billing probably wouldn't process immediately. That's probably handled by a billing service, and so you're not going to see that charge immediately on your bank statement. It's going to take some time to get done, right? So another advantage of messaging is that we can do these long-running processes. We can do them offline and not have to worry about presenting a poor user experience to our users. So we have this sleep in our code. So if we come back over here and we place a new order and we immediately get that new order, you can see that it's in a pending shipment status state. If we look at our consoles and look at our order service, we can see that in the time it took for me to get back here, the order had been shipped, the message has been consumed, and the order shipment status has been updated. So if we come back over here and check the status again, we can see that our shipment status is now shipped, right? So essentially that is the overview of messaging and how to use it in your Micronaut applications. It's very easy. There are a lot of CLI commands that can help you bootstrap your classes. The classes themselves are very easy to use. In the case of the producers, it's just an interface that you have to declare a method signature for that gets implemented for you at runtime. So that's it. Essentially, that is how Micronaut uses Kafka, or how you can use Kafka with Micronaut to do some messaging between services. Now, setting up Kafka locally, running it from your command line, very easy. As you saw, within 30 minutes, we got an application up and running talking to a local broker. Now, what about, of course, everyone's in the cloud these days, right? So what about the cloud? What happens when you go to the cloud? Well, you could certainly turn up your own instances, your own VMs. You can install Zookeeper. You could install some Kafka brokers on your own VMs. You could manage all of that. You could worry about all of that. And that's perfectly fine. That's a perfectly viable solution. You would have a solution that works for your application. But why would you want to do that when there are options available to you? And in particular, in the Oracle Cloud, there is a service called the Oracle Streaming Service. Now, the Oracle Streaming Service is a message broker, message streaming solution that is a fully managed service. You don't have to set up servers. You don't have to install any software, maintain any software, worry about outages, worry about updates, worry about security. All of that stuff is taken care of for you. And this service sits in the cloud. Now, I know you're probably asking yourself, well, that's great. That's helpful. That's handy. But I don't want to, I'm happy with Kafka. I'm happy with the APIs. It works great. It integrates great with my Micronaut application via this Micronaut Kafka project. Why would I want to use your third-party APIs to interact with a new streaming service? And that is an amazingly brilliant observation. Nothing against that argument. And my answer to you would be, what if you could use Oracle Streaming Service with the exact same code that we just looked at in our application? And I know I sound like a salesman right now, and I apologize for that because I am not trying to. But honestly, it's so easy. It's so exciting to me as a developer to be able to use this. It's fully Kafka compliant, right? It works with all of the Kafka APIs. The only thing you have to do is set it up in the cloud, And you can automate that via Terraform. You can automate that via the CLI, the SDK, any of those things. You can get your topics up and running and basically just swap some configuration and point it at that, and you're good to go. How do you do it? So the Oracle streaming service, you go to Analytics Streaming, and you first create a stream. Now, a stream is essentially in Oracle streaming service, the stream is what we think of as a topic in Kafka. So in the case of this example, we're going to need an order topic and a shipment topic, or order stream and a shipment stream. Same thing. The next thing you're going to do is create a user, create a group, apply some policy to that user, and generate an auth token. So that's going to take you 10 minutes of time. And if you are interested, I have a blog post that walks you through all of this. The link will be in the end of the slide deck, and really basically walks you through step-by-step how to do all this. So you create a user, group, policy, and generate a token. Now, the final step here is to generate this, generate a string using a specific format, and that's going to be set as what's called the Kafka SASL JAS config variable. Now, this is what that looks like. It just uses this format here. You plug in your username. Go back here. Plug in your username as the tenancy name / username. Then you put a slash and then use your stream pool OCID. And then for the password, you use that auth token that we generated in the previous step. And again, check out my blog post, walks you through all these steps. Very easy, very simple. So once you have this Kafka SASL JAS config variable, you plug that into your application and you run your application and everything works just as it did before. So let's take a look at that. Let me shut down my shipping service and my order service. And we'll go over to the application oss.yaml file and take a look. So the configuration is just slightly different. In this case, we're going to use the Bootstrap server of streaming and then the given region that you're working with in Oracle Cloud using that same 9092 port. And you tell it the security protocol is SASL SSL. The SASL mechanism is plain. And then you pass it that JAS config. Now I've got that set as an environment variable in my run configuration. So if I switch to that environment, that run configuration, and I run that, and then I come back over here, take a very quick look. It's exactly the same thing in the order side. You use that same configuration, set that same environment variable. And if I switch to that run configuration and start that up, in just a few seconds here, in this case, this one's already good to go. And if I scroll up in the startup output here, you can see here that it is indeed using the Oracle Cloud Bootstrap server. So scroll down here, come over to our order service, and now the order service is up and running. And if I switch over here and I place an order, the order flow should work just as it did before. So if I wait a few seconds after I've placed a few orders and I check the order status, you can see that the status is updated to shipped. So excellent. The only thing I did was create a stream in Oracle Cloud Dashboard, generate some user and some configuration, plug that in. I didn't change a single other thing. I didn't change any of my consumers, any of my producers, any of my code and my services at all. Just pointed the configuration at the OSS server, and it works just the same. Now, the nice thing about this is if we come over to our Oracle Cloud Dashboard and we log in, because we were timed out while we were presenting, as soon as I get logged in here, you will see that if we come to the streaming page and we take a look at our order topic, for example, we can load up the recent messages from the dashboard. And these are only the ones that are published in the last minute. So let me place a few more orders here and we'll be able to see those. Okay. So the nice thing is you can kind of see a snapshot of what's going on in your streams or topics right from the dashboard by pulling up and loading up the recent messages. So excellent. So really, what more is there to say? It's super easy. You create some streams in the cloud. You don't have to worry about managing. You don't have to worry about updates or maintenance or any of that security, any of that headaches. It's all managed for you. You swap out the config and you're good to go. What about RabbitMQ? So we talked at the beginning about AMQP. Well, the awesome thing is Micronaut also has support for RabbitMQ using the AMQP protocol, and it's really easy to use. It's going to look very similar to the Kafka support, and Ahmed, I will answer that in just a minute here. So I won't forget you. I see your question there, but I'll come back to that. So what we need to do here is get RabbitMQ up and running first. And this is not something that Oracle has a service for that you can subscribe to and use in the cloud. But I do have a blog post. Again, if you check the links at the end of this presentation, I have a blog post that shows you how to get RabbitMQ up and running in a VM. It's really simple, and you can, in fact, RabbitMQ, the nice thing is RabbitMQ out of the box gives you AMQP, but there's also a plugin for MQTT that you can enable on RabbitMQ, which gives you that MQTT support. And I use that quite a bit myself for IoT projects that I use. So again, as I said, MQTT is really handy for IoT. So I have all kinds of projects. In fact, one that I'll be blogging about very soon that you'll learn how I'm using MQTT. But I digress, and back to RabbitMQ. So RabbitMQ, the first thing we need to do is create a queue. And you do that through the admin interface that they provide for you. And then once you create a queue, you create an exchange. So I created an exchange called Micronaut Demo. And then once your exchange is created, you need to bind those queues to that exchange, right? So I have an order queue and I have a shipping queue, and I just bind those to the Micronaut Demo exchange. And once that's done, everything's ready to go. Everything's going to be ready to listen for messages. And to create your producers and consumers, in this case, you use the mn create RabbitMQ producer and mn create RabbitMQ listener commands to generate those same classes, similar classes, just as we did before. Now, if I come over here and make sure that these services are shut down, that we're using Kafka, and I hop over to my order service RabbitMQ, this requires a bit of configuration. Again, in this case, RabbitMQ configuration needs a URI, a username, and a password. I'm not going to generate all of the code for you this time, but we'll take a look at it. In this case, very similar. We have an interface called an order producer. This time, instead of Kafka client, it's annotated with Rabbit client. And we pass the name of the exchange to the Rabbit client annotation. And instead of a topic annotation for the method, we have a binding annotation. And this one takes the name of the queue that we created. And if we look back at the presentation here, it actually contains the routing key of the queue. So down here, the routing key of the queue is what you use in that binding annotation. So, and we have a send method signature, and this one receives an order. Take a look at the shipping consumer. Again, very simple, similar. In this case, a Rabbit listener, and you pass it the executor. In this case, actually, I won't get into that because we're going to address that in just a minute. So ignore the executor for just a second here. But if we look at the receive method, it has a queue annotation and it accepts the name of the queue. So this is the queue that we're going to produce on, in this case, the shipment queue. So everything else is the same, right? In this case, this is when we're receiving shipment notifications. So we're getting the order, we're setting the status updated, we're updating the order. So if we run that and we come to our shipping service RabbitMQ, I won't show you every bit of this, but again, very similar. In this case, our order consumer, and it has a receive method. It creates a new shipment when it receives a new order. It has a slight delay, so on and so forth. So this will work identically to our Kafka-based version that we looked at just a second ago. So the order service is up and running. The shipping service will be up and running in just a second. All right, the shipping service is up and running. Now we can place a few orders. Clear our history here. Place a few orders and see they're in pending status. And we wait just a second and check our most recent order. It's already shipped. So again, AMQP works just like our Kafka example. And messaging works just the same, right? So excellent. Let's head back to the slides. So one thing I do want to note, and this is what I said I would come back to, is that you can control the number of threads that are used for both Kafka and RabbitMQ. So if you want multi-threaded message handling, in other words, you do not want to block every time you receive a message, you do have to specify, you do have to, in your configuration, create an executor and give it a name. In this case, the name is consumer. So if we look at this example over here, in my Micronaut application, I have executors and consumer, and I tell it the number of threads that we want to use here. And then in our listener, we tell it which executor to use. I believe, I could be wrong. I am wrong. You cannot pass it in the annotation, but if we come over to the order service Kafka and open up one of these consumers, I believe, yes, you can pass the number of threads to be used to the Kafka listener. So for the Kafka, if you want to change the amount of threads that are used for your consumer, you can control that via the Kafka listener annotation. But when it comes to RabbitMQ, because it's a slightly different project, you do have to pass it. And again, out of the box, I'm not sure why this is, but out of the box, RabbitMQ will not use multi-threaded consumers unless you specify this number of threads in your configuration. So definitely, if that's your intention, that's fine. If that's your use case, that's great. But if you do want multi-threaded and you do not want to block while your activities are happening inside the consumer, specify the number of threads like this. And essentially, that's it. I know I've gone a little long here. I apologize for that, but I do hope that you found this useful and helpful. And very happy that everything seemed to have went off without any errors. I will make these slides available, and all of these links are, again, inside of the slide deck. Here's some code repos on GitHub for all of the examples as well. So if you want to look at the final examples later on, see how I did something, follow up on something, check those out. Here are my socials and contact. I blog quite frequently on the Oracle blog, on the Oracle developers blog. So check my blog out on all kinds of various topics, cloud related, database related, Micronaut related, things like that. Also at recursive.codes. Follow me on Twitter, connect with me on LinkedIn if you want to be my new best friend, and check me out on GitHub or shoot me an email. So if you have any questions, please do place them in the chat and I will take a look at that now. So Ahmed asks, does this have to be done with Micronaut? And you asked me that question when I was talking about the Oracle streaming service. So I'm going to assume that you were talking about the Oracle streaming service. And the answer to that question is no, absolutely not. Oracle Streaming Service can be used with any Java application, basically any application that can take advantage of any of the Oracle Cloud SDKs, which we have SDKs for Java, we have SDKs for JavaScript, Node, Node.js, Python, Ruby, and Go. I think those are all the SDKs we have. So you can use any of those SDKs to produce and consume messages via the Oracle Cloud SDKs, no problem. And I've done it with Node.js. I've done it with all kinds of things. You can also use just pure Kafka APIs. And I think one of my blog posts actually shows just using the pure Kafka API that is produced in the open source version. You don't have to use Micronaut at all. If you have a regular Java application, a Spring Boot application, a Quarkus, whatever you're using, and you pull in the Kafka APIs as a dependency, you set up that Sazzle Jazz config string as I showed you how to, and use the Kafka APIs, works just as good. Works great, no problem. So no, you don't have to use Micronaut when it comes to interacting with Oracle Streaming Service or Kafka in general, really. There's all kinds of client libraries for Kafka. There are client libraries for RabbitMQ, all kinds of things. So definitely not limited to that. I just wanted to show you how easy it is to do with Micronaut, because Micronaut is an amazing framework. Again, if you're not familiar with it or not using it, I strongly encourage you to learn about it. And if you have any questions, feel free to reach out. The creator of Micronaut, Graham Roche, actually works in Oracle Labs and is doing amazing work. And so, we have the resources on hand to the Micronaut, the keys to the Micronaut kingdom, so to speak, are within Oracle. So that, I don't believe there are any other questions. What is at introspected? You did ask that, Ahmed. Take a look at the Micronaut docs. It's an annotation that specifies that Micronaut should introspect that class at compile time. And you could read more about that in the Micronaut docs. But yeah, that's about it. Unless there are no other questions, I do want to thank you wholeheartedly and warmly for joining me today. And I hope you found this session helpful, and we will see you next time. Thank you.